Okay, so today we are going to be talking about solving systems of inequalities by graphing. So this is pretty much the same thing that we've been working on. The only difference with our inequalities is that we're going to have to figure out if we are graphing a solid or a dashed line and what direction we are shading in. Other than that, this is the same thing that we've been doing with regular linear equations. So our first step when we're going to be graphing our linear inequalities is to make sure that we have both of them in slope-intercept form. So remember, that's going to be the y equals mx plus b format. So remember, if it's not in slope-intercept form, our main goal is to get that y by itself. So we're going to do the opposite operations and get the y isolated by itself. After we get it into slope-intercept form, we're going to use the slope and y-intercept to graph both of those inequalities. And our two decisions are whether it's a solid or a dashed line. So remember, if it's a solid line, it's going to have an equal to symbol underneath it. And if it's a dashed line, it's going to have a less than or greater than without the equal to. After we decide what kind of line we're going to connect them with, then we've got to decide if we're shading above the line or below. So remember, if it's above the line, it's going to be a greater than symbol. And if it's below the line, it's going to be a less than symbol. So those are the decisions that we've got to make other than regular graphing. So after we go ahead and graph both of those inequalities and shade in the correct direction, our last step that we're going to do to identify the common solutions is to highlight the region where the two shaded regions overlap. So where they overlap are going to be all of their common solutions. So all the ordered pairs in that region are solutions for both inequalities. And if there is no overlap, then we would write that they don't have a solution in common, or we would say no solutions. Okay, so let's go ahead and look at an example. So our first example, we've got y is less than or equal to 5x plus 2, and y is greater than x minus 2. So for both of these, they are in slope-intercept form already, so we do not have to convert them. So all we're going to do is go ahead and make all of our decisions about graphing before we start to graph. So from our first inequality, we're going to go ahead and identify our slope and our y-intercept. So our slope is going to be 5. And remember, since that's a whole number, we can put it over 1. So we're going to go up 5, right 1. And then our y-intercept is a positive 2. So that's where it crosses the y-axis. And then we're just going to take a quick look at our symbol here. We've got a less than or equal to. So when we're graphing with an inequality, if it's got the equal to underneath, it's going to be a solid line. And if it's a less than symbol, that means we're going to shade below. So we've got all of those decisions already figured out for us. And then we're going to make the same decisions and pull out the same information from the other equation as well. So once again, we're going to go ahead and find our slope and our y-intercept. So again, if there is no number in front of the x, remember that we have a 1. Because 1 times anything is just itself. So our slope here is 1, which means we're going to go up 1 over 1. And then our y-intercept is a minus 2. So this one crosses at negative 2. We're going to go ahead and take a look at our symbol. It is a greater than symbol without a line underneath. So if it does not have that equal to sign, that means it is a dashed or dotted line. And since it's a greater than symbol, this time we're going to shade above. Okay, so we're going to use both of those sets of information to go ahead and graph. Okay, so we didn't have to do step 1 because they were already in slope-intercept form for us. But now we've pulled out all of that information, we're going to go ahead and graph. Okay, so I'm going to start with that first equation. So we're going to do that one in blue, or inequality. So again, we crossed at 2 on the y-axis. So I'm going to put a dot where 2 is, and then our slope tells us to go up 5 over 1. So I'm going to count up 1, 2, 3, 4, 5, and over 1. And then we're going to try and make the straightest line we possibly can. So I'm going to put a third dot on here. And I'm going to try to make these lines as straight as possible. Since I'm using a touch screen, I can't use a straight edge. Okay, so that one was a solid line when we connected. And now we're going to shade below the line. Okay, so that's the graph of our first equation, or inequality. And then we're going to go ahead and swap over and graph the second one. So when we connect that one, remember that one's going to be a dotted line. So the y-intercept for that one was -2. My slope was 1, so I'm going to go up 1 over 1, up 1 over 1, and I can put as many dots on there as I want to help me make a straight line. And then remember, this one's going to be dotted. So it's not going to be connected because it does not have an equal to sign underneath. Okay. And then for that one, we shaded above the line. So we're going to be shading in this direction. So now what we're going to do is we're going to look at where those two graphs intersect. So where those two shaded regions cross over each other are in this section right here. So this is where our common solutions are going to be for these two inequalities. This is where the overlap is. So these would be the solutions for our system of inequalities. So now you guys might have a question, like at the bottom here, it's asking us, is 3, 2 a solution for the system of inequalities? So all you guys have to do, there's two ways that we can decide this. We can either plug in those numbers to the system of inequalities and solve to see if it makes true statements, or we can just go ahead and graph this ordered pair on the coordinate plane and see if it's in that overlapped section. So I'm going to go over to 3 on the x-axis and up 2, which would land me right here. And that's the ordered pair 3, 2. So since that is in the yellow shaded region, yes, that is a solution. All right, so you guys go ahead and try the next problem. You guys are going to be first putting those into slope-intercept form. So again, I'm going to do that. I'm going to go ahead and convert that first one for you guys to remind you guys how we're doing this. So for step 1, if I don't have it already in slope-intercept form, all I'm going to do first is move anything that's on the same side. So since we have a 2x on the same side, I'm going to subtract that from both sides. And then we would get y is greater than negative 2x plus 3. And then we're going to do the same thing with that second equation, or inequality, keep saying equation. And we're going to bring that one over here, and we're going to say it was 4x minus 5y is less than 5. And then again, since we've got an x term over there, we're going to subtract that from both sides. And then we've got, for this one, we've got a negative 5 on the y. So we're going to have to divide by that negative 5 on every term. And remember, when we do that, this is going to flip the inequality symbol because we divided by a negative. So we're going to get 4/5 x and negative 1. So these are the two inequalities you're graphing for this one. So don't forget when we do practice problems that if they're not in slope-intercept form, you have to convert them. So go ahead and figure out what your slope is, your y-intercept, figure out if you're shading above and below, and go ahead and graph your equation in your notes. And then answer the question below whether that solution is on the solution set. Okay,